specific topic. So yun yung gusto nating malaman. Ano pa yung mga bago? Kasi yung mga di-discuss dito ngayon more on either close to the commercial scale, no? Or ano na, medyo well researched na ng mga examples. Okay? So start with solar energy. Ayan. So for solar energy, mas familiar tayo kasi sa photovoltaic, you know, but actually there are other technologies that utilize solar, solar power. Okay? Iba-iba yung mechanism ng pag-utilize ng solar energy or energy from sun. Okay, so this is one example using mirrors, no? And focus siya sa tower. And later on, mag-discuss pa to, no? Some example, saan sila naka-install. So, okay. So, types of solar power, there's what you call active and passive. Yeah. So, medyo familiar tayo dito. For active, ito yung kino-collect mo, ni-utilize mo, no? Merong conversion ng solar to other applications, electrical or power, and then heating. Yan. So dito sa active, ito yung mga ways on how to utilize solar energy. Yan. Through heating, using hot water panel and through photovoltaic cells. So by converting, actually ngayon, ang kaya is visible light and a little bit of the IR to generate electricity. So visible light region ng light spectrum yung nako-convert, no, mostly by PVs. So later on, I'll be explaining that as well. So from light energy to electrical energy. So, pwedeng to power appliances, no? So from powering appliances to heating, yan yung mga applications. So for passive, yan, essentially tina-trap mo. So for passive lighting, usually to lighting and heating. So you have to design the house to get the most most hours of sunlight, no? And then syempre storage of heat para during nighttime you have heating, no? Without the use of electricity kasi na-store mo na yung heat during the day. Okay, so passive yung tawag doon. So mostly these designs are actually implemented to countries where you have 4 seasons. So dinidesign yan para yung mga bahay, yung mga buildings, para mas makapag-collecta sila ng mas mahabang liwanag sa araw. At syempre, ma-utilize yung heat sa gabi pag malamig na yung panahon. So meron tayong mga parang yung thermal materials, no, to store heat. Ito, another example, again, energy from sun is stored in, we call it thermal mass. So again, sa mga countries na 4 season, they have PV, photovoltaic, to convert sunlight to electricity, and syempre. Minsan yung setup, solar, tapos gagamitin yung solar for electrolysis, no, ng water to produce hydrogen gas para sa hydrogen fuel cells. May mga ganito namang setup, no? So solar to H2 to syempre electricity. Merong isang intermediate. Okay, so 'pag thermal mass naman yun nga, we store the heat, then later on we use that when there's no more sunlight. So for active solar, yan meron tayong mga parts 'no, ewan ko kung nag-DIY kayo na sa mga bahay pero kayang-kayang i-DIY 'to, eh, medyo mahal lang. Pero, merong basic parts yung isang, PV system. So, of course, you have to have the photovoltaic panel, meron siyang mga connections, so ang mga popular components niyan, ayan inverter, to convert, DC to AC 'no, and then siyempre kung dalawa yung, puwede mong gawin 'no, puwedeng yung power generation goes, to your, homes 'no, to power your appliances. And then if you have extra maybe, you can employ net metering. Kaya dito if you will see dito sa, left side nung illustration, or left side nung inverter, yan meron kang, um, power grid connected to AC sa left side ayan, utility instrumentation, tapos may metering, tapos power grid yan yung binebenta. Tapos sa right side, may metering din, then, AC distribution center. Ito yung sa mga houses most likely 'no, or kung isang bahay lang sa mga appliances. So meron tayong, tinatawag na net metering. Siyempre may requirement yon. So for example sa'tin sa Pilipinas, hmm, I think may certain, ah, bill ka, eh, amount ng bill billing 'no, electricity billing para mag-qualify ka to sell or makapag-net metering ng solar power. Not sure if it's 10,000 or may certain, kilowatt, hour consumption. So, kapag gano'n, bibilhin ni Meralco 'yun ng mas mura 'no, kaysa sa, presyo na binabayaran mo sa kanila. Usually mga nasa 50% lang. So, for example, ₱12 per kilowatt. So, si Meralco bibilhin nila ng ano 'yan, ₱6 ganyan, ₱6, ₱7. So, halos 50% ang ano, discount, gano'n. So, pero okey na lang din kasi if you're producing extra, 'di ba, kaysa masayang, mabenta mo siya. Pero malaki yung effect, sa bill kapag meron kang, PV. Kaya lang yung footprint niya medyo ano, malaki din. But again, maybe 'pag meron ka na sufficient yung generation, uh, you can have ROI, ano, as early as 3 years, no? On the average mga 3 to 5 years. So this is an example naman ng large scale solar electric site. So kung merong mga DIY sa mga bahay-bahay, of course we have what we call the solar farms 'no. So they're, large scale klase. So they're arranged, dito an example walang nalagyan ng label. So yung iba sa desert 'no, arid naman, parang hindi istorbo sa farm 'no. Pero sa Pilipinas wala kang choice kasi, ah, wala naman tayong disyerto 'no. So, talagang may tatamaan na hmm, land na you can use for farming, may mga gano'n. Yung iba of course nakita niyo naman yung sa sa Ilocos. Ano bang pangalan niyo sa Ilocos? Sino nakapunta doon? Tama 'di ba sa Ilocos, nakalimutan ko yung pangalan nung solar ano dun, ay sorry, wind pala yun. Sa saan ba may pinakamalaki nito? San Carlos and, sa Cavite, I think meron din 'no, Cavite din. So yun yung malalaking ano, solar farms. Dito may mga nakita kayong malapit sa Metro Manila? Meron ba dito? Nakakita na ng solar farm na medyo malapit-lapit sa Metro Manila? Wala. Sa Cavite, alam ko meron sa Cavite, eh.
Sa Naik yata 'no,
Oo, alam ko
sa
meron.
Cavite.
Pero nakita niyo na yun, nasilip niyo na, hindi?
Ay, hindi pa daw.
Ayun
Pero may
'no,
may na may nasabi malawak daw dun sa Naik.
mm, mm. So akala niyo maliit, eh, 'no, pero 'pag pinuntahan mo yung farm mismo malaki talaga din, malalaki din yung mga installation, yan. So dapat ma-maintain din yan kasi may mga factors, affecting the performance of solar PV, solar photovoltaics. So yung mga dust, yung heat, yan. So may ano yan, kailangan ma-maintain din, okey. So, for large scale solar electric site, so 'pag, photovoltaic medyo straightforward ano, from light energy to electrical energy. Pero kapag may tinatawag tayong solar concentrators, concentrate the sunlight, or the heat from sun to, heat up water to form steam, 'no. So, essentially gano'n yung nangyayari, and then siyempre you have the steam turbines to generate, electricity, ano. So, later on we will give, some examples yung design nila, ano itsura, 'no, and then ano yung temperature na nare-reach, um, during the process. Okay, so the steam yun nga goes to generate electricity similar to, fuel cells or nuclear power plant. So, yun yung typical, 'di ba? So, init, convert yung water to steam, then you have the steam turbines to produce electricity. Advantages, of course, you don't release any air pollutants kasi it's not from combustion. Okay, but drawback, of course, is that you can't produce electricity at night. So, meron siyang additional cost, 'no, through by ano, putting up energy storage systems. So, for solar photovoltaics, typical yung battery. For solar concentrators naman, so we have, um, yung mga salt materials to store heat, yung mga high capacity, heat exchange capacity ng mga materials para mag-store ng heat for a longer period of, yung heat na na-store na yun, again, will be used to produce steam, for your steam turbine. Okay, they also do work on cloudy days kasi, either photovoltaic or solar concentrators. All you need is to focus the light. For photovoltaic, all you need is light. Kasi mamaya later na-explain ko kung bakit kahit cloudy puwede pa rin namang makapag-produce kahit papaano. Siyempre with lesser efficiency 'no. Okay, so as discussed kanina yung passive 'no, mostly for light and heating, ayan. So kailangan yung design mo, tama, yung building design mo ay tama para ma-maximize mo yung light and at the same time makapag-collect ka ng heat. Works on the principle of hot air rises and cool air sinks 'no, or yung convection. Solar heats the air, it moves through convection to the structure or to a thermal mass. Okay? So, again yung design 'no, ma ma aangat yung mainit, pababa yung malamig. So, it's actually advantageous for people kasi nasa ground naman yung, naninirahan sa mga buildings o sa bahay. Can get cooler air to passive, uh, heating. And then of course at the same time, you can collect heat. You can collect heat in your thermal mass para, like, at night, the stored heat can be used for, heating. Sa ibang bansa 'di ba, 'pag nakikita niyo yung gilid ng pader merong mga radiator 'no. So dun pinapadaan yung steam para ma-maintain na init ng bahay. Kasi nga especially during winter, sobrang lamig. So, yung mga radiator na yun nasa mga gilid-gilid ng bahay, mahal din yung, binabayaran. Kasama sa bill yan, eh. Bukod sa kuryente, meron ka rin billing for ano, for heating. Hindi siya libre. Kaya naalala ko noon, nung nag-ano ako, visiting researcher, nag-Spanish program ako sa abroad. Dun ko kasi ginawa yung study ko for a year, eh, nataon na during ko, ah, dumating during fall, autumn 'no, autumn papasok ng winter, napakalamig, eh, siyempre sanay tayo sa mainit. Tapos ang problem yung radiator dun sa loob parang sinet pa ng low or parang sira. Sobrang sobrang lamig. Eh, ang laki-laki ng binabayaran siguro ang bill ko nun nasa almost 40,000 a month para dun sa apartment. 40,000 a month, imagine halos halos kalahati ng allowance ko napupunta dun. Tapos nangangatog ka, so nireklamo ko. Kaya nung naayos, sinet ko ng parang Pilipinas, parang tropical. Siguro temperature sa loob nung bahay, eh, mga nasa 30 yun. Sinusulit ko yung bill ay yung bayad ko kasi yung mga nasa 30 degrees. Kaya paglabas mo ng bahay, biglang sasalubong sa'yo yung sobrang lamig na hangin. And sa period ng yan, yeah, pa-winter na. Actually, nag-stay ako dun hanggang January. Eventually, nakahanap ako ng mas murang part. Sayang dun. So, gano'n ano. Kaya siyempre yung ibang bahay ang dine-design nila passive 'no, hindi gagamit ng radiator 'no, hindi gagamit ng electricity to heat up kasi and of course you save energy kung design like this. So, ito yung klase ng mga design. So, you have the mass wall, yung kaninang thermal mass na tinatawag. Okay. So, again, may convection, cold air, sinks, warm air rises. So, dito sa design, dalawa yung configuration. No? Merong pinapapasok yung init, meron namang pinapalabas yung init. So, siyempre, ang ideal kapag winter is papasukin mo yung init, di ba? Pag summer naman ay palabasin mo yung init. So, yung design ng bahay mo dapat nakaayos based on the season. No? So, itong pinapakita dito, yung arrangement dito. Yung mga thermal mass mo, yung wall, should be configured accordingly based on the season. Para during summer, ang pumapasok ay cold air or nilalabas yung hot air. During winter, pinapasok mo naman yung warm air at pinapalabas mo yung cold air. So, through the principle of convection. So, ito yun, to rest of house. Ito yung mga design. Okay, so, depende. I think sa atin sa Pilipinas, para ma-maximize naman yung sunlight sa mga nag-set up ng solar PVs, I think should be oriented to the south, no? To get the most sunlight in a day. Pansinin niyo yung mga solar farms, no? Even dun sa mga commercial buildings na may solar panel, kung paano ina-arrange yung kanilang photovoltaic panels. Okay? Solar power's pros and cons. Solar power, pro, abundant. If you will check, no, actually yung energy na pinoprovide ni sunlight is more than enough to supply the energy demand of the whole world, no? Global demand. Sobra-sobra. Unfortunately, hindi yung technology ay challenge pa hanggang sa ngayon. Kasi more than enough, but the technology is not that advanced yet to satisfy yung ating energy demand through the use of solar energy alone. So, yun yung isa sa mga challenges. Okay, but it's very abundant, no greenhouse gases, walang emission, no combustion, no combustion. Simple, minimal repair, and cheap over the long term. As mentioned, yun nga, ang ROI niya nasa mga 3 to 5 years. And then the rest, papakinabangan mo siya ng mga 20-25 years, yung PV. So, okay na rin. Kaya lang yung footprint medyo problem nga pa rin kasi yun nga, may mga components din siya, syempre. Battery storage is one thing, no? Yung disposal niyan can be a problem as well. Efficiency, yes. Sa ngayon, yung mga commercially available, mga nasa 25 . 25%. So, we are yet to see commercially available na nasa, let's say, 35%. Yung mga research, 30%. Wow. Yung mga research cells, as of now, nasa almost 50% eh. Efficiency pa lang. So, mababa pa rin talaga. Pero, ayun, no? Maganda if we can convert that. It's more than 50%. So, yung mga kapag-produce na yung mga commercial cells na gano'n ang conversion. Ang cons, ayan, so retrofitting needed if structure is not already designed as passive solar. So, ano, yan, retrofitting. Ayusin mo yung pagkaka build, no? Yung building. So, maglalagay ka siguro ng mga additional ano, installation just to ensure that you get the most out of your setup. Has limitations, obviously, you know, there's no sunlight at night. Okay, and then some locations better, such as south, southern or north facing slopes. Yeah. Kasi ano na, oriented na agad sa south, no? Kung yung bahay mo oriented pa norte, problema. So, yun yung isa sa mga challenge. And then initial capital outlay KPI. Totoo naman. Ewan ko kung nagdi-DIY sa inyo dito. But yeah, medyo expensive pa rin naman. Kaya nga ang ROI, medyo may katagalan. So, 3 years to 5 years. But you can feel naman yung impact sa billing. Ayan, let's check the solar potential. First, we are situated in the tropical area, no? Region. So, walang problema ang Pilipinas when it comes to solar energy. Negros is considered to be one of the best solar locations for solar farm. This is from NREL, National Renewable Energy Lab of the United States. So, ito yung kanilang map for solar potential. And see here, sa atin yung mga highest natin is on the range of 6 to 6.5 or 6 to 7 kilowatt hour per meter squared. I think this is area, no? So, kilowatt hour per meter squared per day. Yun yung solar potential. So, around 6 to 7. May mga region syempre na medyo mababa. Let's say, ayan, no? 1.5 to 5. So, I think yung mga regions na medyo mababa ay medyo mga mountainous areas. No? So, kung tinignan mo yung mga mountainous areas natin, let's say the Cordillera, Sierra Madre, no? Medyo green siya. Pero 4.5 to 5 still not bad. Okay, Palawan, medyo ano, may area na mataas, may area na mababa. Tapos, Metro Manila, NCR, okay, nasa range din ng ano, hindi, 5 pala to, medyo green, no? 5 to 6.5 pala. Hindi ko pala 7. But ideal, syempre, it's, yun, nasa 6.5 to 7 and up. Ito, mas malaki-laki. Okay, that's why, ang mga sikat dun sa San Carlos, sa Negros, may Negros dito. Itong, may pointer ba to? Nakita yung pointer?
Kita, Dok.
Yes po, sir.
Oo, yan. So, ayun. I think dito sila nag-produce 'di ba sa Iloilo kayo? Panay is okay,
Opo.
Panay is okay, Negros is okay, Cebu is okay. Uh, Magandang locations for installation of solar farm. We are yet to see solar concentrators later on. I will show you. But so far kasi ang well-established technology kasi is photovoltaic, not the concentrators. Siguro medyo magastos din yung concentrators. But it can be a good study. Ayan, siyempre you have the Samar Leyte region. Mindanao is also nice. Okay, and then Central Luzon up to Pangasinan. Pero yung mga mountainous area medyo mababa. Next. Ano close to? So, based on NREL study, the average solar potential of Philippines is around 5 to 5.5 kilowatt hour per meter square per day can be generated. So, kung kaya yung solar potential, yun yung kilowatt hour, that's already energy. No? Energy, sunlight, no? Energy that can be produced in a day per square area, per square. So, kumakain din talaga ng space. No? Ito na yung sinasabi ko kanina, no? Solar concentrators. Solar concentrators. Kasi tayo medyo familiar tayo sa solar photovoltaic, mga cells, no? Mga modules. But, ayan, according to history, mas nauna pala talaga to. Kaya lang sumikat yung yung photovoltaic o solar PV. Mas nauna pala yung mag-concentrate ng solar power. In 1767, the first solar collector is able to reach 30 degrees Fahrenheit. Ano yung temperature niya sa Celsius? Kumukulo na to di ba? But this is about 100 into 30 degrees Fahrenheit. Kaya na mag-produce ng steam niya ito. 230 is, ano siya? Check natin. Ayun, taas, no? Nagpas sa boiling. So definitely, you produce steam. Pero saan kaya siya ginamit? 1878, yung init gumawa ng ice, no? So we have solar-powered ice maker. And then we also have solar-powered furnace. Actually, ang luma na ng technology, pero hindi siya pumatok. Ano? For some reason, na-discover si fossil fuels, no? Naging ganun eh. Parang ano lang din yan, yung sa petroleum, same thing. Before, yung mga, di ba, si diesel engine, ay original design yan ay to be powered by vegetable oil, di ba? Peanut oil. Eh, na-discover si petroleum. Wala na, nakalimutan na yung original design ni diesel. So, ito similar din nito. Siguro na produce yung photovoltaic or I don't know, for some reason, pinace out itong mga to. Kung ito ay siguro na-develop since 1700s. Advanced din talaga yung technology natin when it comes to solar concentrators. Solar power furnace, may mga estudyante nag-research din nito. Solar dryer, etc. Then we have solar power distillation. Obviously, ginagamit pa rin natin itong ganito, pero yun nga, in a smaller scale pa rin, is used by the French Legion. course, still used today. Survival 'to, 'di ba? Water distillation tayo using solar power. Mahalaga 'to especially during disaster, survival, maganda meron kang setup for the solar water distillation. Ayan. So, again, this is overview. 'Pag tumungo na tayo doon sa mismong per topic, I will be discussing more examples, more technologies under solar power, and of course, itong mga succeeding topics. But those examples are a little bit old technologies, but still under research, some of them. So again, as expected from you, should be discussing naman yung mas modern na technology under the assigned topic. Okay. So today is just an overview of the topics in the course. So wind, may question by the way sa wind ay sa solar? Wala. We can proceed to wind. Okay, sige. So wind power, ayan. Meron kayong nakitang ganitong setup sa Pilipinas o puro lahat ay nasa lupa? Example of a wind farm naman. Kanina may solar farm, this is a wind farm. Meron ba sa Pilipinas na ganito? Are you familiar with this kind of setup installed in the Philippines? Mostly sa lupa, no? Tama.
Yes po, sir.
Yes, sir.
Pero ba dito taga Rizal? Yun yung pinakamalapit eh. Pero pang taga Rizal dito. Doon sa Pililla. Kaya mga nagbabike papuntang Rizal. No? Wala. So dito, sa Rizal kita-kita natin eh. No? So we go to a place close to Rizal and in tall, high or tall building, you can actually see the Pililla windmills. No? Kita niyo yung pinakamalapit. Pero syempre, there are also other installations around the Philippines. The most popular siguro yung sa Ilocos. Ano bang pangalan mo sa Ilocos?
Bangi, sir. Bangi Windmill po.
Bangil. Sa Pililla, sa Pililla nakita ka na sa Guimaras, nakita ka na rin. Actually, marami pa eh. Pero ito, yet to see this kind of setup sa Pilipinas. Pero nakakita ko nito sa Taiwan. No? Sa Taiwan meron silang ganito sa tubig, sa dagat. So wind power, okay. Before the invention ng wind turbines, the original application of wind power is for mechanical applications, such as the pumping of water, milling ng grains. Ano ba tawag sa Pilipino na milling? May local ano ba tayo doon? Hindi bista eh. Pero bang Filipino word for milling? Nangyari sa bigas. Sa dialect, pero mang popular na term ginagamit. Or yung common na term na ginagamit. So yun, milling grains. So now, it can be used for the generation of electricity, and can also be so for direct use, it can be stored also in batteries. Yan, so ito yung mga lumang ano, windmill talagang pang-agricultural application. Yan, those mechanical power windmills are high torque and low speed. Nakita niyo talagang mabagal pero malakas, no? So essentially to pump water, yan, sa milling, grinding grains, and cutting of wood. Nakakita na rin ako ng mga ganitong classic, no, na windmill pang farm. Yan. For electrical power windmills naman, maraming design yan. Siyempre, ang very popular yung sa wind turbine is high speed, low torque naman. High speed, low torque machines to produce electricity and then will turn themselves off if wind speed exceeds the limit. May certain limit yan. Pag yung wind velocity sobrang lakas, baka magkaroon ng turbulent reaction, turbulent flow. So, pwedeng makasira ng yung turbine. So, meron silang stopping mechanism in case the velocity is too much. But high speed, low torque, sila for sa generator mo. Okay, so ito ilan sa mga designs. Okay, a smaller scale, mga micro wind turbines. Ito yung usual na makikita mo mga design. But of course, there are so many designs. Ayan yung mga nire-research natin. How to improve the efficiency. And syempre, similar to photovoltaic, pwede mong ma-install sa mga bahay-bahay, no? Sa mga smaller communities without too much capital cost. So yun yung challenges sa atin mga engineers na how to come up with the design that is efficient and low cost. Pros and cons. Yan, so walang greenhouse, same with solar. A few other pollutants, maybe noise. Kung mapapansin nyo, mga wind turbines, medyo maingay. Medyo nilalayo rin sila sa community. Okay? It's cheap. Okay nga, free naman talaga yung source yan. Pero yung installation is not cheap. Of course, tapos po wind turbine, medyo, ano siya. Pero wala kang, wala kang, baga feedstock. Abundant, of course, air is just everywhere. And it's simple. So, for cons, we have noise pollution. Yun nga, na-mention ko kanina. Ayan, metal blades, yan, interfere with the reception. So, it can disrupt yung TV and radio signals. No? And then, it can be an aesthetic pollution kasi structures so big. Okay. So, there's no evidence for bird death daw. Hindi naman malaramang nakikita pa na papatay na but head kill bats. Siguro na ano sila sa vibration, sa echo na guguluhan sila. So we go to wind power in the Philippines. Again, this is obtained from NREN, National Renewable Energy Laboratory. Maybe if you have the chance to visit there, would be nice, no? Or do research, maybe. And sa mga mahusay na energy institutions sa US. So wind power in the Philippines. ito yung ating wind power potential. Kung mapapansin niyo dito nasa norte nga 'no, nasa norte yung mga malalakas mataas ang potential. So here you can see can produce yung mga red nasa 3,000 to 5,000 megawatts. Imagine 'no. Then the minimum wind power is bigyan tayo ng pointer. Yan. So minimum wind power ay 300 watts per meter square. Dito ang turbine size, maliit nga lang 'to, 500 kilowatt lang ang nakalagay. Baka maliliit lang na ano 'to 'no. So the following assumptions were used in calculating the potential wind, electric capacity. So Philippines has a total of 78.8 gigawatts kung makabitan pa ng solar farm ano. Pero again, hindi lahat ng areas ay suitable for wind pala sorry, wind farms 'no, suitable for wind energy. For example sa Mindanao, medyo mababa talaga siya. Mindanao will be suitable for maybe solar farms and other technologies, but not wind power 'no. May mga places na sa Pilipinas na medyo okey. So for example sa Ilocos region, sa Palawan is also nice. Ito ay Quezon, tama? Quezon region, maganda din. Maybe up to Rizal, Quezon and Rizal regions are okay. Tapos sino sumunod diyan, yung mga purple 'no, ayan. So ang Negros, very blessed ang Negros, maganda siya sa solar, maganda pa siya sa wind. Yan kasi ano, ang taas. Yung Guimaras nga, which is, nasa Panay, ay hindi pa nga kasing taas ng sa Negros, eh. But yun nga, may mga nakita kong wind farm sa wind turbines sa Guimaras. Okey. Mas malinaw. Kitang-kita siya 'no. Ayan, you can see Palawan, Quezon, and Ilocos regions are the most ideal candidate for installation of wind energy systems. Ayan. So, na-introduce ko rin kayo dun sa commercial at saka sa small scale 'no. Kasi yung commercial large scale yan, iba yung design niya sa mga small scale. Pag nag-discuss tayo ng, wind energy, ano na specific that for the topic, mas marami pang mabibigay na examples pagdating sa design ng mga micro wind turbines. So later on, we will see them. And of course, sa presentation niyo kung naka-assign kayo sa wind energy, you will be able to see other designs. Tignan natin yan. Any question by the way? So far wala. Walang reply ko lang po. Ayan, sorry. Narinig ako? Okay naman?
Dinig, Doc.
Okay. Okay, okay. Sige, let's continue. Hydro. So hydro, same thing as the wind, can originally be designed for mechanical application. But now, we can use it for power generation. So in the 1700s, so hydro is actually employed for watering, for irrigation. Similar to windmill. Windmill can also be used for irrigation. Hydro is also used for irrigation back in the 1700s. Now, of course, when electricity was discovered, engineers, scientists trying to find different sources to produce electricity. So, ito, yung mga dams are actually developed in the early 1900s para makapag-produce ng electricity using water. So, potential energy to kinetic to power water turbines. Yeah. So I think familiar na kayo dito sa design ng hydropower. So we need to have a dam or reservoir to store, to have that potential energy, and then syempre bubuksan siya to let it flow downwards to run ating turbines. Of course, you have the generator to produce the electricity. So you connect in connection with the turbines. So yung parang may dynamo. So the dam is attached to the power plant. Ayan. And then of course you have to have the potential energy head. So you could estimate the power or energy that can be produced. So the power is distributed to your transmission lines. However, the impact of dam is quite big sa ecology, no? So maraming pwedeng mga sira. No? Kasi you'll be flooding the area. So there will be for sure loss of flora and fauna, no? Dispersal of communities, no? Especially kung mayroong mga indigenous people doon or mga local communities within the affected area, they have to be transferred, no? They have to move. Otherwise, malululog sila doon, mababaha sila. So yun yung environmental impact ng problem pagdating sa mga ganito large scale power production from water. So ito nga, as mentioned, there will be flooding, displacement of not just people but animals as well. There will be climatic changes. Of course, you're constricting, no? Or changing the natural flow of water. Local climates will be affected. Tectonic activities, yes, possible. Kasi nga, pabibigat din yun, meron kang head potential. Earthquakes, tremors can be experienced. Loss of life, loss of species, aquatic interest, flora and fauna as mentioned, can happen for sure. Yung mga locally living animals, no, and plants, and maybe even indigenous, pwedeng affect. Loss of normal nutrient flow, that is also true. Kasi nutrients can come from mountains, no? And if you stop or slow down the flow, so distribution of nutrients will for sure be affected. So nutrients kailangan yun sa halaman, kailangan din yun sa isda. No? So, ay yung mga bagay na yun. kailangan din ng tao. And then also there will be changes in the temperature of water kasi nga the flow is impeded. But for sure there will be changes in the temperature. The pros ay can generate electricity, can also do mechanical work, no greenhouse gases, because there's no combustion. Initial construction provides jobs for sure because dams are so big. It requires so many people, no? A lot of manpower is needed to construct. Yeah, that's why it can provide jobs in the initial construction. Ayan. So, either na tayo, stops na tayo. Hindi ko nakita. Nakunan tayo ng example. Malaki lang yung example natin. I'll just show some examples. Sa Pilipinas, ako nag-research tayo sa for sure, no? Wala. Wala. Ito very crude example. Post. Nakikita ba na nag-i-edit? Hindi.
Kita po, sir.
Ito parang Pilipinas lang itsura. Pero yung smaller scale, ano? Ito for sure, ginagawa na to ng mga estudyante natin sa Pilipinas. Especially sa communities. Pwedeng i-DIY. Ayun, isang example. Ito lang dito. Kasi sa atin dito sa Pilipinas, inaano na natin. Ginagawa na nating extension project. Sino ba nasa ano ngayon? Marami rin ba sa inyo nasa academic? Yung nag-work kayo sa academic? Or most of you are sa private. Si Jasper pa yung nasa RTU.
Yes po, sir.
Ito si Sis Payet, nandyan na. PUP pala.
Yes po.
Tsaka si Navarro, si Emerson. Joshua and Emerson, nandito na ba sila? Hindi nakapasok.
Ay, sir.
Nandito po, Dok.
Ito na pala.
Ay, sir,
Okay.
papasok ko lang ako, sir. Pasensya na po.
Okay. Ayan. So, nandito na pala.
Oh.
Pero, teka lang, ba't ganun? Ang affiliation mo is Bataan Peninsula State University. Pero
Yes.
you are a project development head?
Opo, sir. Sa mga infra po. Infra.
Okay. Sa IDU.
Opo.
Kasi tawag sa amin dito sa TUP, Infrastructure Development Office.
Opo, sa amin po project development.
Okay. Ano ba sa iyo? BAPSU ba to o BPSU lang?
PPSU lang po, sir. Bataan Peninsula State University.
Oo. Okay, so nasa ano ka pala? Project development. Hindi ka nagtuturo rin.
Dati po nagtuturo, pero nagpalit po kasi ng university president, kaya nalipat po ako sa infrastructure.
So full, no? Wala palang ano yun. Hindi siya parang faculty with admin. Hindi siya ganun.
Hindi po.
Fully admin ng designation.
Opo.
Pero yung plantilla mo, meron ka ng may item ka?
Ngayon pa lang pong taon, sir, yung plantilla.
Pero ano bibigay sa'yo yung engineer, hindi instructor?
Sakon po, ay po, engineer po. Medyo mataas-taas po compare sa
Instructor.
teaching. Opo.
Pero paano tataas pa yun? Hindi na tataas yun.
Hindi po tataas po yun, sir, pagka natapos ko po itong masteral.
Ano yung ibibigay sa'yo? Engineer pa rin?
Engineer pa rin, pero tataas po yung SG.
Ano ang pinakamataas na engineer na plantilla?
24?
Mataas din
Opo, mataas din, sir.
SG24 para sa ano?
Po, mga ganun.
Pero hanggang doon na lang siya, SG24.
Opo, siguro, sir. Pero yung starting po, SG, yung mga bagong pasok, SG12.
Na engineer?
Na
O
engineer.
instructor?
Hindi po, engineer po sa infra. Tapos yung instructor 1 po, ang
Ganun din.
starting
SG12. Tsaka matagal. Pag engineer, bilis pala ng SG24.
Opo.
Equivalent to Professor 1 yun.
Opo, bali yun na po yung sa namin, yung director ng infra. Yun na po yung kanya, yung SG.
Kaya lang wala kayong JC. Hintayan yan. Hintayan mabakante.
Hintayan. Opo.
Yun yung medyo challenging din.
Opo.
Mataas pala.
Opo. Okay, sir.
Ayan, dagdag na natin to, no? So, kanina yung mga example na pinakita natin doon ay for example, yung dam, no? So, it can be from mini to large hydro. With large hydro, you can produce more than 100 megawatts. So, medium, small, mini, then you have the micro hydro, and then you have the pico hydro. So, typically, yung mga inaaral sa universities, nire-research mga estudyante sa graduate programs, ay nandito lang sa scale na to, micro pa ICO. From 5 kilowatt to 100 or less than 5 kilowatts. So ito yung mga inaaral natin ng different designs, different configurations. Hindi lang for research but also for extension sa mga nagtatrabaho sa academia. Kailangan meron din tayong community extension aside from research. So, ayan, it's an example of a FICO kasi again, explained, it's less than 5 kilowatts. Siyempre, meron ka pa rin kahit pa paano ay sort of reservoir or source, no? flowing water. If it's in the mountain area, then it's okay. You have the free flowing. You just need to direct the flow or at least connect yung penstock. And then you have to have the turbine. Turbine can also be designed so that it can be efficient in collecting and converting the water to electricity. Okay, so ito is 5 kilowatts, pero can be used already by the communities to charge phones, maybe produce light at night. So 5 kilowatts actually, pwede rin yun. May TV ka na rin dyan, no? TV, radyo. So, pero if it's just lighting, it's more than enough to power a few houses or even community. Okay, so ayan yung typical na research na may mga designs din yan. So hopefully in your presentation, you can find more designs, a better setup. Okay, let's proceed to tidal power. It's just an illustration. I think this actual, not an actual picture. So tidal power, medyo similar sa water as a hydroelectric. So meron ka pa rin kahit pa paano medyo sort of storage, no? Meron kang konting head para magkaroon ng flow, no? So here in tidal power, you essentially place a dam across an ocean inlet. And harnessing the energy as water moves in and out of the dam. So in and out, may side na mataas yung tubig at this time of the day, and then may side na sa kabila naman, different time of the day. Essentially, ganun yung nangyayari. And through those movements, you can harness or get energy from different tidal movement. Okay, there are of course positive and negative effects similar to hydroelectric mga dams. So here you have the tidal dam. So create siya ng barrier para ma-channel yung flow, no? Papunta din dun sa mga water turbines. Later we can see illustration. Yeah. So here, ito yung nangyayari. Ito hinati nga eh. So you have your sluices, and then may part na papasok siya. So high tide for example, so mag-create ng flow papasok. Yan. So parang may mini dam ka sa loob. Okay, ang flow papasok. And then, syempre dadaan yun sa mga turbines mo to run ng power. Okay. And then pag exit sa isang side ng river, dun yung medyo mas so mataas, no? Dun yung tataas eh. Ay pagpababa, so you have pagpasok ng turbine, syempre sa kabilang side yung exit niya, which is higher than the one entering doon sa sluices part, no? So yung flow essentially parang ano lang, paikot-ikot lang. Now, pag low tide naman, so reverse lang din yung mangyayari. So dito sa illustration on the right side, tide coming in, and then tide coming out So you can see the difference in the elevation or yung height ng water. Okay. And dapat yung design ng turbine reversible din, ano. So when low tide happens in the day, pag nag-reverse yung flow, your turbine should still run and produce electricity. So essentially parang gumagawa ka ng mini dam, no? And you're using the tides to fill up your dam. No? So ganun yung principle mo. Hindi pa rin pala. Ayan. So ito yung mga different designs ng tidal and wave pattern. Kanina tidal siya, no? Ito nga sa upper right ay wave, no? So yung iba naman utilizes the water current. Diba? Malalakas din ang current sa ilalim ng dagat. So you can use the water current to run yung mga turbines or propellers to produce electricity. So napakaraming design actually. And in your presentation, maybe we can see more innovative designs. You're going to check the efficiency and maybe know where it is ideal to set them, no, up. Example, whether it's suitable for the Philippine terrain, no. So also some certain locations that are ideal for these technologies to be deployed. Hopefully makita natin yun in your presentation. Hindi ko na ilagay yung ano dito. But this one is for waves, upper right. Upper left ay for the tidal and at the same time water currents. Kasi ang blade design niya is pang moving water. No? So, wait, yung ano ka dapat yan, may current ka. Ito, pinakita yung sa lower left. Yan, yung kita dito yan kapag submerged na siya sa water and then there's water current. Doon nag-regenerate ng electricity. May ibang design naman na parang yung electric pan na no? Bladeless, parang gano'n. Kalimutan ko yung pangalan nito. So later on we will find out. Ito pala, upper left, maybe this is similar dun sa, lower left. Similar dito sa lower right. Ayan. So it's a 1 megawatt RT3 unit. Check natin kung ano ibig sabihin ng RT3. So baka ano to, Reynolds transport theory. Yung iba tidal watt tidal watt. So sa tides pa rin. Later on we will give more examples. Yung mga floating. Okay, sige. Sige, ano lang naman to introduction. Later on sa lecture for specific to the topic, we will provide more examples. It's just an overview. Ayan. So, ito, namatay na to Sino taga dito? Taga Samar? Wala na ng balita dito. So, the Lupini Blue Energy Project is supposed to put up. Pero for some reason, siguro merong no resistance from the community. I'm not sure if this project has pushed through. Parang wala. Nabalitaan niyo ba 'to? Wala na, napakatagal na nito, eh. Kalimutan. Uy! Narinig ako, narinig.
Yes, Doc. Rinig po kaya.
So, itong sa Dalupiri, tagal na nito, eh, 2000 pa. Not sure if this is still okay. Wala na tayong balita dito. Sino ba taga-Samar dito, meron ba? Meron ba ditong taga-Samar? I don't know what happened to this project. Wala na yung balita. Parang puro ano lang, discussion lang. 2015 yung pass. Tingnan natin po sa susunod. Parang nasa siya. Alam ko na. Yung late kasi merong publication, eh. Akong publication. Dalupiri, no? Dalupiri. Dalupiri reality process. At 2017 sa Science Direct. Dalupiri Island. Okay. Wala na masyado talagang balita. Plan. Okay. Okay, sige. Nakita na ako. Tagal na ito. Pre-construction 2027. Pre-construction pa lang yun. It's just a plan. Pre-construction 2027. Lagay na. If ba yan? Pwede ba malagay ito? Check ko ba lalagay. Ano? Ayun. Kita ba? Nakita yung nilagay ko. Hindi.
Yeah, Doc. Habang na sa ibang slide yun, Doc.
Ha?
Hindi makita, Doc.
Makita. Ulitin natin. Ganda kasi magkasama na sila. Okay. Gets po. Hello, narinig ako? Putol ako bigla.
Yes,
Naririnig?
Doc. Dinig po kayo, Doc.
Okay, okay.
Dinig po.
Bigla ako naputol. Nag-update kasi itong Teams eh. Medyo ang hirap gamitin. Ay, hindi na-share ko. Ayan, nakita na? Naka-share?
Yes, Doc. Kita, Doc.
Yes po.
Itong sa ilalim nakita. Details about the WPRI.
Yes,
Nakita
Doc.
yung
Kita,
table?
Doc.
Oh, ayan. So, phase level project details. Ayan, it's pre-construction 2027. Yan, ang tagal na ng pinag-iisipan pero ano pa pala, 3 years from now pa pala. Ayan. So, 500 megawatt capacity onshore kasi they will be building sort of dam and will be managed by Itbayat Island UPC Asia Corporation. So, ito, hopefully matuloy na to by 2027. Marami sigurong consultation kung pinagdaanan to and maybe there are some resistance from the community or maybe from the local government. But yeah, we will see. 500 megawatts is quite big as well. Okay. Let's proceed. Ayan. Biomass energy. So, medyo popular din po sa mechanical engineers. Ano? Biomass energy, I have actually some advices in the project program doing biomass energy. Torrefaction, briqueting, gano'n. So, tayo ginagawa rin naman natin ito in the industry. Especially doon sa may mga farms. Okay, so these are some of the pictures of systems, technologies that utilize biomass for power production. So, yung mga co-firing technologies. Biomass pros and cons. Of course, is burning and obviously with combustion, you emit combustion gases. So pros, you can burn or get rid of solid waste. Say it occupies space, decomposes as well. But you get to burn them, use the product for heating and of course power generation. Creates energy, creates new markets for crops. Meron tayong tinatawag na energy crops. Solely for power generation. solely for panggatong, no? Meron ganun tayong energy crops, especially in other countries. Talagang kino-cultivate nila yun, for biomass energy. Cons, it releases greenhouse gas, no, in the form of carbon dioxide and maybe other gases. Combustion yan, may NOx din yan for sure kasi nitrogen from air. So yun, other gases associated with combustion. It creates also solid waste from ash, but at least in a minimal or reduced volume. Kasi solid waste na kaya agri waste, talagang mas malaki yung volume nun compared to the ash that will be produced. Okay, may cause more grasslands to be planted with corn or sugar. So, convert yung grasslands to agri or crop production. Tapos na ba? So, ito ang example. Dagdagan natin. What's next? Okay, malapit-lapit naman na tayo. Na-cover ko rin ano yung iba. Okay. So, aside from co-firing, we can utilize biomass to produce liquid fuels. No? Ayan. For example, ethanol production, you have the sugar producing crops. No? In the Philippines, the most popular is the sugarcane. Direct yun kasi yung mismong sugarcane extract or juice already contains simple sugar. So simple sugars can be fermented to produce alcohol, the form of ethanol. Essentially, ganun yung nangyayari, no? Meron kang molasses, it starts with the molasses. After you extract the juice, no, from the sugarcane, of course, yung biomass ng sugarcane after extraction of the juice can be used, no, for co-firing din. So pwede mong i-dry, gamitin yun, yung mga residues ng agri waste for co-firing for your boilers. But the molasses is stored and used for the production naman ng ethanol. No? So from molasses storage to clarification, siyempre you need to ferment. No? Kailangan i-ferment yun para makapag-produce ka ng alcohol tsaka carbon CO2. And if you want to concentrate, syempre this is just mother liquor. It's a mixed liquid with the juice, the alcohol, you know, and other byproducts of fermentation. You have to distill to concentrate your alcohol. So, depende yan. For example, if it's a drink, so if it's a liquor or a wine, or kahit hard na lang, let's say gin, for example, should be distilled up to around, ano lang, 80 proof, around 40% lang alcohol. But if you are going to use the alcohol for as a fuel for gasoline engines, no? For transportation, for power generation, it has to be 100%. Or tinatawag natin ng absolute ethanol, for example, or absolute alcohol. So you have to distill it up to 100%. Actually, you can reach 100% through distillation. So you have to put chemicals to remove the remaining water in the alcohol mix. No? Kasi meron tayo total na azeotropic parang part kung saan ayaw na maghiwalay ng tubig sa alcohol. So there's always an affinity between water and alcohol. We use chemical treatment to remove the remaining moisture. Now, ito, denature. Kasi may, kapag ethanol kasi, di ba, nakukonsume. So, medyo mahal yon dahil may parang sort of part of the food tax, no? To reduce the cost, denature. Naglalagay tayo ng other forms of alcohol which are toxic. To usually nilalagay natin ay methanol, no? Sometimes iba pang mga chemicals that are toxic to denature ethanol and make it unsuitable for human consumption. So in a way, the cost is reduced. No? It's not subject to any more additional tax pa, especially sa food. Yun. So yung produce na denatured ethanol na yon or alcohol will be mixed with gasoline. Kaya sa Pilipinas, yung ating gasoline is actually, ano ba yun? E10 din sa Pilipinas, no? Or E50. It's actually E10. I'm not sure if nagtaas na siya. So that means 10% of gasoline that we use is with ethanol. No? 10% of that is ethanol. Denatured ethanol. Okay? So, ayun, no? So it's 10% of that is mixed with gasoline, then that's what we actually buy from gasoline station. Okay, the government gives incentives. Anti-biofuel act if companies use renewable fuel. Kaya yun yung ano naman advantage of and of course the environmental impact of using renewable fuels. Okay? So ito yung isang utilization ng biomass. So we have the sugar ferment to produce ethanol. So not just sugar cane, but also corn, yung mga starchy. So anything with starch with carbohydrates, you can ferment to produce ethanol. So yung mga lumalabas na products and byproducts. Biomass energy, ayan, meron tayong status dito. Biomass generation has grown up to 1.6 gigawatts in the Philippines. So these are some of the biomass power generation in the Philippines. Of course, this is close to farms, no? So we have there in Iloilo. We have there in Bukidnon. So Iloilo, anong crop sa Iloilo? Sa Mina? Bigas ba?
Yes, Doc.
Okay, so bigas, no? So sa Mina, naman yung mga agri-waste doon ginagamit. Bukidnon, obvious naman ang Bukidnon, that's pineapples. Pero ngayon, ginagamit na nila ay biogas. And so nag-expand na rin sila, anaerobic digestion na rin, biogas digesters na rin. Ini-employ nila to utilize their agri-waste. San Jose Lipa, yung taga Batangas dyan, ibang tanim doon. Buko. San Pedro Laguna, baka wala na to. Ayun. I'm not sure what's in San Pedro. Manukan ba? Poultry ba? I'm not sure. Pebaysiya, obviously, Central Luzon, yan, bigasan yan. So these are areas, no, locations in the Philippines that utilize biomass energy. For sure there are, kasi 2011 pero other more, no? There are more biomass energy plants in the Philippines. No? Because this information is more than a decade ago. So biomass materials such as rice, yun, rice chaff, rice straw, corn pala, kasi nakalimutan. Empty shells of palm. In Mindanao, we have a huge palm plantation. Kita ko yung mga truck doon, may mga bunga ng palm. And strain piece of corn. Okay, last na to, geothermal energy. Geothermal energy. Ano ba yung technology na discuss dito? Sa co-firing lang pala, tsaka fermentation. Okay, geothermal energy, very well established ito sa Philippines. Okay, pasok tayo sa top 5 geothermal energy producers in the world. Ayan, so we have the following locations in producing geothermal power. Ayan, yung Ban TV, which are managed by Chevron, YTC. So mostly they are located in areas where there is a sort of active volcanic activity. Kasi yung magma, it's actually needed to generate steam underground. So kailangan may heat source ka. And normally you can find them in areas with active active volcanic activity, active volcanoes, or close to there at least. May heat source, thermal source underground. So Macbaning TV, managed by Chevron. EDC naman, nandyan si Tongonan, Leyte, Palimpinon, Bacol Mount Apo in Mindanao, and Negros. Okay. Which part in Negros? I think this is Negros Occidental, no? Northern Negros. So ang lalaki, 426 megawatts, 330, 112, 600 megawatts. Mount Apo, a little bit small, 108. And the smallest Northern Negros, 49 megawatts, reached by PLOC. Pero pag tinotal mo to, ang laki. So that's why Philippines is one of the top producers of geothermal energy in the world. Not that much new technology when it comes to geothermal energy. Maybe the innovation in technology when it comes to geothermal power is on the drilling, maybe. So how to tap the steam underground. So maybe that's the area where they improve the technology. But as of producing, very well established and there's no problem. Or maybe corrosion siguro, yun. When it comes to producing energy, there's actually no issues for geothermal systems. Maybe corrosion, drilling, siguro yun yung mga challenges yung geothermal power. Pros and cons, so again, can be used for electricity generation, even space heating. Kasi nga yung steam can be collected and distributed for cooking and other low temperature industrial application. Yung mga heating ng sa food preparation sa food industry, pwede. Pros again, it's inexpensive after initial outlay because your feedstock is free again. It's getting from underground. Pros again, there's no greenhouse gas emissions, but maybe there is sulfur, depends on the quality of your steam. Cons, same problems as we see with oil rig. Kaya nga na-mention kanina, maybe it's difficult to tap yung steam. Kasi more or less, you will be situated in a mountainous area. Kasi doon yung volcanic activity. So drilling can pose a challenge when it comes to recovering your steam. And localized distribution. Tama naman because not all cases have an active volcanic system. Harnessing geothermal. Ayan. These are some types of drilling. We have this rock, and wet system and dry system. For wet system, heated water below ground is used. For dry system, you send above the groundwater. Ipapump mo basically. You pump the groundwater to the source of heat. So sends above groundwater below ground to get heated. So meron kang parang siguro hot rock sa ilalim ng lupa. Tapos doon mo ipapump yung water from the ground to convert that to steam. Siyempre may pangpalit ka ng steam once it becomes heated. No? So yung wet system, yung mismong water, galing na sa ilalim. And paakyatin mo na lang. Mga pressurized system yun. No? Papunta sa mga, sa mga steam turbines po. Okay, so resulting steam can be used for a number of purposes, of course. So for heating and for power generation. Okay, so to close, this is the energy mix. Ay, let's say, meron pa ako no slide energy mix for the Philippines. But by definition, an energy mix is using more than one form of energy to meet the needs, energy demand. And it's also important to ensure that we have long-term demands are met. So you have to have a right energy mix to make your energy production sustainable. So in the Philippines, hindi lang siyempre, obviously, isang klase yung pinuproduce natin, but it depends on the location and the suitable technology needed for those identified areas. What else? In ecosystem ecology, diversity is equal to stability. Hindi ka dapat mag-rely on one technology. Kailangan may bala, may may isama mo yung iba pang mga sources of energy meron ka. Okay, so for example hindi tayo pwede mag-rely lang sa fossil fuels, no? Sa coal, for example, sa fuel oil, for example, or any fossil fuel based sources of energy. Hindi pwede tayo mag-rely doon kasi eventually they will run out, no? And they'll deplete and of course also destroy the environment. So we have to transition to maybe almost 100% renewable. So depending on only one form leaves problem. So ito ay isang example ng energy mix for the Philippines, and I'm not sure if how old is this data, but for geothermal energy, Philippines the second largest, no, sa top 5. We have an additional capacity, potential additional capacity of 1.2 gigawatts. Ganun kalaki. For wind in the Philippines, it We have a resource potential of 700 megawatts, the largest in Southeast Asia. And yung sa North Wind Power, which is 33 megawatts, it's actually the first wind farm in Southeast Asia. For solar, we have, medyo iba na ito, we have 1 megawatt grid protected solar of Cepalco. Ayun, may mga mas malalaki na dyan. Cepalco is, ano ba ang pangalan yung cooperative ba yan? Ang gumana ng Cepalco. Cagayan de Oro. Cagayan de Oro, ang Cepalco. Philippines is Southeast Asia's largest solar manufacturing hub. Unfortunately, nag-exist pa rin ba siya? Nagsara na. Alam niyo kung sino yung company na yon? Before, we are the largest manufacturer of solar PVs. Ngayon ay alam ko nagsara na.
SunPower ba yun, sir?
Yan, SunPower. Bukas mo ba yung SunPower?
Parang bawas po ata sila ng tao, sir. Gawa ng, natatalo ata sila ng manufacturing sa China. Yun po
Yes,
yung
yeah.
sabi nung kakilala ko dun sa SunPower.
SunPower. But before, we are, the Philippines is the largest solar manufacturing hub in Southeast Asia. Okay, current capacity was 400 megawatts of solar cells. In the Philippines, 100 megawatts. Okay. Mini hydro. Yeah. We have mini hydro, 1.7 gigawatts in total for 888 sites. And biomass, 235 million metric barrels of fuel oil equivalent. Capacity, actually potential pala ng Philippines when it comes to biomass. Bagas alone, no? At alam mo, iba. So ito yung sasabi natin, energy mix, we shouldn't rely on only one form of energy source. No? So our target, 2030 target, hindi na hindi pala na isama yung dito, yung fuel cells, fossil fuels. Pero our target is to have additional capacity of 9.8 gigawatts of power. You know? And more than 50% of that comes from hydropower. Micro siguro yan, really. Medyo, kasi yung pagpaik ko community-based lang siya. So, I'm not sure if it's profitable without. Pero yung mga mini hydros, okay? And then, next to that is geothermal. So, kung hindi tayo mawawala sa top 10, no? Sorry, wind pala. Wind. So, hydro, wind, solar is only 3%. Ang lakas ng production ng wind, 34%. Yung footprint nito, mas maliit kaysa solar. Okay. Yeah. Probably because wind is available. No? 24 hours. No? A day. Unlike solar kasi, medyo problematic siya dahil sa storage ng battery lang kasi. And then ocean energy 1%, biomass 3%. So ito yung target ng Philippines by 2030 additional 9 point or about 10 gigawatts from renewable energy. So maraming areas to explore in doing your, let's say, research, thesis work, so many options, no? Especially during the energy engineering program. Hindi lang actually technology, you can also do modeling, you can also do energy audit, etc. etc. So maraming options, it depends on your interest. Kung anong research ang kung gusto yung gawin, no? Or i-specialize. Okay, pagdating ng time na mag-thesis na. Okay, I think this is the last slide. So, yung mga following meetings, we will be covering yung nandun sa listahan. We will start with solar energy. We will be discussing some computations, some calculations, and syempre yung technology, common technologies, and some of the recent advances of the topic, let's say, solar. Some of the recent technologies, the researches being done under solar energy will be covered in the next lecture. But again, as I've said, in your presentation, we expect more innovations, more discoveries, more novel designs, no? And when the time comes, so that we can supplement what we have learned in the book. Okay. Any question, clarification? So ngayon, ito may time pa naman kayo. Hanap-hanap na kayo ng mga papers ninyo. Balak i-discuss or i-present sa class. It's again first come first serve basis. Kaya mas maganda, mas maaga yung mapa-approve yung papers para magaling kayo makapag-prepare ng presentation and yung briefing.
Ay, sir,
Okay?
sir, tanong lang po.
Sige po.
Yung ating pong
Naputol siya. Wala si Charlton. Ako ba naririnig? Hindi.
Yes, Doc. Narinig po.
Okay. Si Charlton yung naputol. Narinig niyo ba? Anong tanong niya kanina?
Naputol po yata siya, sir.
Ay, okay. Baka sa headset. Okay, anyway, sige. Mamaya pag pabalik siya. May tanong pa? Additional? Question, clarification? Nag-disconnect na talaga siya. Clear ba yun? Ay, sino ba yung si Emerson? Aware ka ba dun sa mga requirements na na-discuss last time?
Hello, Doc. Hello.
Hello, oo.
Sir, mag-ask na lang po ako kay Sir Roel.
Okay.
About daw
Anyway, may recording naman.
Apo.
May recording nung previous meeting.
Apo, Doc.
Diniscuss ko naman sa earlier part yung Actually, yung meeting lang na yun. Diniscuss ko yung mga requirements.
Yung first meeting, Doc.
May recording naman. So,
Apo. Pero pag may question naman po ako, nagtatanong
yes.
Kay Sir
Sa
Roel.
akin, pwede rin.
Sa inyo rin po.
Oo, pwede.
Pasensya na, sir.
Yes.
Ngayon lang ako nakapasok at
Okay.
Kasi hindi ako na-join kagad sa MS Team.
It's okay. First meeting, second meeting pa lang naman yan.
Medyo na-late ho ako, sir.
No problem.
Salamat, Doc.
So, as mentioned, in-emphasize ko parati yung ano lang naman, mga requirements, you need to submit your requirements. Basis tayo for the computation of grades. Ano?
Hello,
And then,
hello. Hello, Doc.
yes.
May question po ako.
Okay, sige.
Bali, sir, kung po kasi ako, MEP. Ano po ba tungkol natin? Subject po ng MS.
MSME.
Opo, bali,
Oo nga. Oo.
MEP po ako, Doc. Bali, actually, sir, penalty subject ko po to.
Okay.
MEP po ako, sir. MEP, parang, ako na lang po yata naiwan sa MEP.
Okay.
Bali, wala po kasi ako ma-enroll na subject, kaya napunta po ako sa subject ng MS.
Okay lang, wala namang problema.
Okay lang. Medyo, siyempre po, iba po kasi yung subject ng, mga subject po ng MEP sa subject po ng MS. Kaya po medyo nangangapa po ako sa mga subject sa MS. Medyo, siyempre po, iba po yung subject ng MS sa MEP. Medyo, yun, medyo nangangapa po
Okay
ako
lang.
sa requirements.
Ano naman tayo dyan? Binibigyan naman natin ng time para i-prepare.
Salamat to, Doc.
No problem daw. Hindi na nakabalik si ano
Hindi na
Putol
pala.
na siya. Putol na. Anything else? Meron pa tayong
Wala na po, Doc.
clarification? Okay, sige. Pabalik na ba si ano? Wala. Ayan, yan na si Charlton. Naririnig?
Nadidinig niya na po ba, sir?
Ayan na, sige, okay na.
Okay
Sige,
na. Sorry na.
Putol
Nag-drop
bigla.
po yung signal. Ay,
Okay,
tanong ko lang po kung naka-upload naman na yung syllabus natin, no? Yung take upin po natin sa buong semester po, no?
Dito lang, outline lang binigay ko.
Okay. Pero nasa ano po natin sa platform o nandito lang sa presentation?
Dito sa presentation.
Kala ko nasa ano po sa portal natin. Sa GC.
Sa ERS, wala eh. Walang ganun sa TUP, yung ERS system.
Hindi po, doon sa ano lang, sa Teams,
Sa Teams.
Pwede naman sa Teams.
Pero i-upload ko tong
Atong presentation. Sige po,
Yes,
sige.
yes.